Hello everyone, welcome to our webinar on how Global Formula Racing, or GFR for short, leverages Siemens software to not only accomplish our high-level goals, but to also improve our designs year to year. Before we get started, I'd like to introduce myself and my colleague. My name is Wesley Morris, and I am joined here today by Mike Hilliker. In this webinar, we will first begin by introducing Global Formula Racing as a Formula student team. Then we will cover the high-level returns we saw when using tools such as Siemens NX, SimCenter FEMAP, SimCenter Star CCM Plus, Siemens FiberSim, and finally Siemens VSys. Once each tool has been discussed in detail, we will summarize the savings we saw during the 2021 season, then open the discussion for questions and comments. Global Formula Racing is an international Formula student racing team composed of students from both Oregon State University as well as the DHBW Ravensburg in Germany. Together, each year we design, manufacture, and test 2 electrically powered cars that compete against more than 500 universities in competitions in both the United States and Europe. Even though there is a 9-hour time difference between the 2 schools, the team continues to work around the clock to accomplish our common goal, that is, to win. Our overall team goal is to design and implement a system that will score the maximum number of points at competition, therefore winning said competition. This system includes the car, people, team organization, and project management. Everything we do in design, manufacturing, testing, and management serves this goal. A Formula student competition is composed of both static and dynamic events totaling 1,000 points that push both the people and the car to their full capabilities. The static events include a judged defense of the implemented design, a cost breakdown of said design, as well as a business presentation focusing on real case scenarios surrounding the business of the team. Dynamic events consist of an autocross, an acceleration run, a skid pad run, and a 22-kilometer endurance race or driverless track drive. Teams are also scored on efficiency during this endurance race. Not only are these Formula student events for cars with drivers, but they are also fully driverless competitions that share most of the same events. This year, Formula Student Germany will actually combine driven and driverless competitions to further push universities to optimize their cars for driverless. Our team's design philosophy is simplicity, reliability, and simulation validated by physical testing. We use our team philosophy to guide our design decisions throughout the design phase of our season. We incorporate simplicity to establish a full understanding of our systems within the entire team. And with the endurance event being the heaviest point dependent event, we aim to design a reliable vehicle so we can finish the endurance race without any issues. We use various simulation tools to improve our designs. However, these simulations require physical validation for further improvement of the design and the simulation itself. This year, 2 electric vehicles will be produced, with both being capable of competing as driverless and or driven, with all responsibilities split equally between Oregon State University and DHBW Ravensburg. The first tool we will discuss is Siemens NX, GFR's choice CAD software. GFR has been using Siemens NX for the last 5 seasons, giving us plenty of time to learn and take advantage of the advanced modeling tools that are not available in other CAD programs. Siemens NX has been able to address many of the challenges that were present in other CAD programs, making it an easy decision to implement. Siemens NX's ability to handle large and complex assemblies was a huge advantage over other tools. Not only is NX able to handle large assemblies, but it has also allowed the 2 schools, Oregon State and DHBW Ravensburg, to, in parallel, edit parts and collaborate effectively and efficiently. The implementation of NX advanced GFR's modeling capabilities and also opened up new doors to integrate with other tools commonly used by our team. This integration with other tools will be discussed in following sections of the webinar. The key to being a winning Formula student team is keeping your CAD structure effectively organized, efficient, and stable. We are able to keep our file structure secure and sustainable through the use of version control and advanced permission management, as well as using detailed tutorials during our onboarding process to make sure students are able to mirror GFR's standard practice of keeping within said structure. Not only do we train all of our students to use Siemens NX to the team standard, but we also ensure specific settings are automatically set through the use of a batch file that not only opens the program, but also loads all the correct settings. Once students are finished with the previously mentioned tutorials, they become equipped with skills not offered within either university, like creating advanced surface modeling projects, as well as gaining experience with advanced modeling tools like mechanical and/or electrical routing tools. Siemens NX makes organization and CAD structuring simplistic and easy to understand, not only for new, but also returning members of the team. With associative features within NX, we are able to save over 15 hours trying to fix inconsistencies through our large and complex CAD assembly. Through the use of detailed tutorials created for internal and external use, over 60 hours have been saved onboarding new team members. About 30 hours have been saved using built-in advanced modeling features such as electrical or mechanical routing, with an addition of 40 plus hours saved using the integration between other software packages. Not to mention, NX has saved countless hours coordinating international design work regarding platform compatibility within one CAD model. With all these savings, GFR will continue to push the use of Siemens NX throughout the team to advance our designs and open up new design opportunities. GFR plans to implement Team Center and integrate it with NX to improve and streamline our software management as well as version control. The team also wants to continue to explore the opportunities to integrate with other software tools to advance our design and in turn score more points in competition. Doing so will not only further our capabilities as a team, but will help accomplish our goals and be more successful overall.
Hi, my name's Mike, and I'll be going over SimCenter FEMAP next. So SimCenter FEMAP is one of GFR's keys to success, as it allows us to analyze important structures in as much detail as we need without any sacrifices. Using FEMAP has not only introduced more opportunities for the team to optimize designs, but it also allows for the simulation of advanced materials such as carbon fiber. There are always challenges when it comes to learning new software. Siemens was able to address the challenges of learning new software by creating an intuitive interface that helped our team's full understanding of the FEA process, to not only assist with onboarding, but also to make the optimization of parts more straightforward. While using other analysis tools in the past, the team ran into issues with the desired mesh refinement, as well as the use of more advanced capabilities. Using SimCenter FEMAP, we have been able to refine meshes to the desired characteristics, therefore maximizing our efficiency of the FEA simulations and improving the accuracy of the results of those simulations. Another issue that has been addressed with FEMAP is the ability to keep our CAD models and finite element models consistent during the design and simulation process. FEMAP also offers the ability to pre- and post-process models within the software itself, making the overall simulation procedure much more efficient and intuitive for team members. We try to ensure the sustainability of the team by creating student-made tutorials using our parts as case studies. Using these real-life examples helps fully encompass the understanding of the design and simulation process for all team members. Being able to use CAD models imported from NX as finite element models in SimCenter FEMAP makes the understanding of this process simple and intuitive, while also making sure the models are consistent and accurate. The time saved using the ability to pre-process and post-process models in FEMAP has not only proven to benefit the team, but also produces better results in terms of the component itself. FEMAP has not only allowed GFR to run highly accurate and relatively quick simulations, but it has also allowed us to perform convergence studies on our simulations to better gauge the gains we can make with the tool. The amount of time recovered from onboarding students into the FEA world with self-guided tutorials adds up to over 25 hours, and that can be budgeted somewhere else. SimCenter FEMAP is able to integrate with other Siemens tools that allows team members to accurately and efficiently simulate products from other tools such as NX and FiberSim. Team members are also able to pre-process CAD models within FEMAP to save over 10 hours for the team, as well as another over 10 hours of work for the post-processing of models after the simulation. Through the use of FEMAP, GFR has been able to save about 2.8 kilograms by optimizing and avoiding over-designed parts. We want to continue to use SimCenter FEMAP to help optimize our currently proven designs. We have already saved 68.8 grams in our suspension clevises alone through the use of SimCenter FEMAP. Not only does this result in weight savings, but it also provides us with design information on how to further iterate and improve the designs. As our parts evolve into lighter and stronger designs, we are able to reflect this development with the growth of our manufacturing capabilities. Since these capabilities grow each year, we also introduce new opportunities to look at alternative material types for certain parts. This not only creates the opportunity to use complex manufacturing techniques, but we also believe this will provide more benefits for the team in the long run. GFR utilizes SimCenter StarCCM Plus for aerodynamic component and cooling system design. This software benefits the team by having full control over parameter and environment settings that include meshing options and fluid flow models. GFR relies on the iterative design process to improve overall vehicle performance. For aerodynamics, running many simulations is critical to refining and improving airflow around the vehicle and the aerodynamic components. Students across the GFR team change their part designs in NX and then could import them into a CFD software for analysis. This process can take unnecessary time if entire models must be re-uploaded for CFD analysis. If a student wanted to run multiple simulations with minor changes, like a design iteration, or major changes, like an entire vehicle attitude change, then it would take more time to set up each simulation and run the simulation. GFR team benefits by being able to play macros in StarCCM Plus to automate simulation processes. Creating custom macros that can be easily played through StarCCM Plus has reduced manual hours that would otherwise be used in simulation setup and reduced consistencies between simulations. This ability also improves the onboarding process for newer, less CFD experienced students by having fewer steps needed to produce CFD results. Where StarCCM Plus allows our team to quickly iterate designs and run simulations without completely going through the simulation setup process. The technical lead creates a base simulation file that is shared for students to start out simulating their newly created NX parts without introducing variables that could come from changing mesh or turbulence model settings. Documenting and using consistent CFD settings makes comparing design iterations quick and simple. StarCCM Plus also allows our team to make design iterations and run simulations without uploading entire models. We've saved over 50 hours by only needing the necessary computing power and manpower time to remesh the influence components and run the simulation, which is faster than uploading an entirely new model. CFD simulations allow GFR to gain more competition points by increasing vehicle performance through aero-driven designs intended to increase downforce and reduce drag. The use of StarCCM Plus gives our team a greater understanding of airflow around heat-generated components so that we can meet our cooling requirements. The ability to play macros allows GFR to run multiple simulation steps quickly and automatically. One use of this is creating multi-attitude simulations. Over 60 hours have been saved by reducing the need to manually adjust simulation settings for various attitude studies. Currently, the macros can be easily changed to meet the specific needs of how the student wants a simulation set up. We plan to continue creating and using macros that are played in StarCCM Plus to automate the simulation setup process. With the expansive capabilities of StarCCM Plus, GFR will continue running CFD simulations on the entire vehicle and specific components for increases in aerodynamic and thermodynamic efficiency. The next software that I'll discuss is the Siemens FiberSim. GFR uses this tool to create simulated layups for design for manufacturing of composite parts. So the use of FiberSim gives our team the ability to create plybooks, which are organizational sheets that outlines laminate layers in defined zones. We develop layup schedules from the plybooks to ensure an easy-to-follow process of manufacturing. This simplifies the process for less experienced members to understand how the component should be manufactured. Fortunately, we have a CNC ply cutter that accurately and quickly cuts plies from flat patterns that are exported from FiberSim. This greatly reduced man hours and material waste. Siemens FiberSim is one of the most useful keys to the team's success. FiberSim helps us minimize the amount of carbon scrap made when cutting plies, in turn saving weight, money, and manufacturing time, which are of the highest value to us. This software tool saved us over 90 hours through quick visualization and simple editing of problem areas in ply layups on composite parts. For the chassis alone, we cut down manufacturing time by 50 hours over the last 4 years. Each year, we save on average 2.5 kilograms of wasted material by efficiently designing the ply layups and automating the cutting process by exporting FiberSim to plies. As we increase our material usage efficiency, we can create more parts with that material and spend less time on complex machining. The ability to simulate composite layups allows the GFR team to save material by not needing test layups. GFR also benefits from being able to simply create a composite layup and perform an FEA. GFR plans to further reduce waste material by improving the design and layup of our composite parts. Siemens FiberSim will be used in the future to design more complex parts without adding complexity to manufacturing plans. Design improvements can be made to reduce weight while maintaining the characteristics needed of the part.
The last Siemens software tool to discuss is Siemens DISW, a wiring and harness design tool that not only allows for integration of CAD models, but streamlines the design and manufacturing of the wiring harness for our race cars. Before the implementation of DISW, GFR had various issues surrounding organization and accuracy when creating harness layout diagrams for the entire car. DISW solves both of these problems by allowing the tools for schematics and harness layouts to work together to ensure consistency between them, while also keeping everything much more organized compared to something like a flowchart. With the integration of CAD software, DISW also solves the problem of excess wire lengths where they are not necessary, allowing us to optimize the harness for the car even more. Besides design, DISW also helps to resolve issues within the manufacturing of the wiring harnesses, in the sense that the tool can promote better organization by creating important documents such as bills of materials and manufacturing reports. Using DISW is a major key when it comes to building and manufacturing professional and efficient wiring harnesses. The use of DISW video tutorials provided by Siemens has allowed the wiring harness engineers of the team to get up to speed quick and use the tool as efficiently as possible. Overall, the biggest key to success here is the integration between Siemens NX and DISW. Through the use of NX DISW integration, the wiring harness can be modeled in the CAD model, then wire length data can be transferred to DISW for an accurate harness layout diagram that makes the harness more straightforward to manufacture and better optimized for the car itself. We've also found that the use of sub-harnesses has substantially simplified both design and manufacturing by creating smaller harnesses that can be focused on separately. Not only do sub-harnesses simplify the full car's wiring harness, but it also allows for better organization and structured documentation in the form of schematics and layouts. The use of DISW has not only allowed GFR to minimize the weight of the wiring harness by about 3 kilograms, but it has also simplified manufacturing in the sense that our layouts are more organized, better labeled, and overall easier to follow. The standard for wiring harness documentation has also improved since the implementation of DISW. Not only do we now have organized schematics and layouts of the entire car's electrical system, but we also have said schematics and layouts stored in easy-to-use workspaces that are also capable of creating bills of materials, costings, and manufacturing reports, as previously mentioned. Using VSys has introduced not only weight savings but time savings, as the team has been able to save approximately 20 hours transferring CAD data to harness design software through the use of integration between NX and VSys. With VSys, GFR has noticed not only improvements in weight, but time spent designing and manufacturing our wiring harnesses. That being said, our future plans include more advanced integration of Siemens NX and VSys to hopefully further improvement of the harnesses as well as the design and manufacturing practices behind them. GFR also plans to start implementing Capital Integrator to test new systems and ideas regarding system design of our electric race car that can then be integrated with VSys. In order to further implement VSys within our team, we are planning to continue the development of detailed tutorials meant for internal and external use that compare to those that are used for Siemens NX. In summary, GFR has experienced massive gains and savings by collectively using all of the software tools mentioned above. In total, our team was able to save 253 hours during our design process, as well as 97 hours during our manufacturing process through the team-wide implementation of these software tools, as well as the use of integration between said tools. GFR was also able to save a total of 4 kilograms in system weight and 2.8 kilograms in component weight by optimizing designs using the software mentioned previously. Overall, GFR has firsthand experienced the benefits of using Siemens software and will continue to use it in order to improve our race cars year to year. Thank you so much for joining our webinar. With that, we can open up the floor for questions.
Yeah, so when y'all say you saved, let's say, 97 hours during manufacturing or like 200 hours during design, like what are you comparing it to? Are you comparing it to like other CAD softwares or like other?
Yeah, we compare most of our time savings to previous seasons through our kind of the team structure. We have all of our team members working on specific projects, benchmark their time and how they improved on that time, whether it be in design or manufacturing, assembly. So most of those numbers are taken directly from documentation from previous years and applied here.
Yeah, Wesley, I believe your team has been using NX for quite some time now, so it's not like you guys just recently moved from a different CAD platform to NX. So
yeah. We've had quite a bit of time with a lot of the Siemens tools, so we've been able to see improvements pretty much every year.
Wesley, Lee here. I'm just wondering if for your driverless autonomous development, are you looking at pre-scan, SimCenter pre-scan?
We are not. I did not know that was available. I can definitely look into it and discuss that with you and Chris.
Yeah, it's really worth looking at. It's an autonomous simulator, and its main kind of unique differentiator is the accuracy of its sensor modeling and the ability to introduce realistic amounts of noise and throw rain at it or whatever.
Okay, cool. Yeah, we'll definitely want to look into that.
By the way, I'll just add a quick note for any of the other student competition teams here on the phone. Any of the tools that are mentioned here, of course, you can get access to completely free of cost. So if you want access to any of these tools or have any questions about them, they could be about capability, the licensing, anything along those lines. Feel free to reach out to me. I've got my contact information up here. It's just chris.penny@siemens.com. And I'd be happy to get you guys connected. And also, one other quick note for any of the companies here on the phone, if you have any questions for the team, maybe offline, if you want any resumes or anything like that, I'm sure Wesley and the team would be happy to kind of coordinate that.
I was wondering, you talked about using some macros when you're using Star CCM. I was wondering, like, if somebody had never used those before, how you guys started just learning about them, and I guess like how you could improve using them.
Yeah, sure. So we recently, introduced macros in Siemens or in Star CCM Plus, and we first just looked at the documents that Siemens provides just to get started. We ended up using Java as the route to go that way, and just basically, you'll need coding experience, but basically just writing a custom macro for your needs. So now that now that we've started that, we're starting to try and get more complex processes automated so that we can have more consistency between the simulations.
In Star CCM Plus, there's a little blue record button. When you hit that, anything that you change in the simulation is recorded in a Java macro file. So like if I want a simulation to, hit mesh, hit the run button, and then, it hits its stopping criteria, and maybe you export some scenes or, whatever those actions are, you can literally do those mouse clicks, and every click, every change you make is recorded in a Java macro file. And then when you want it to stop recording, you can hit the stop button, and then it'll spit out that Java macro file that you can then go in and use. And it could be something simple, like one that I use all the time is just one that simply hits mesh, and then once it's finished meshing, it hits with the run button. So it's really simple, but it just saves you from having to wait around for it to finish meshing, and then for you to manually hit the run button. So it just kind of does both back to back. So it can be as simple or complex as you want it to be. And I never had to go in and do any manual like Java coding or anything. Obviously, if you had that kind of experience, it helps a lot. The other thing to consider is Star CCM Plus has something built into it called the Design Manager, and that allows you to do a lot of the stuff that I see teams want to do with automating like design exploration automatically. So like you can give it exposed CAD parameters and say, hey, I want you to go do a sweep or an optimization case or whatever it is. Here's all the data I want. Here's the scenes I want. Go run 20 cases, 100, 200 cases, whatever it is. And it collects all of the data for you and puts it into kind of one cohesive environment. So that's that comes with the licensing. So it's built right into the software. So something else to kind of consider.
So during onboarding for like FiberSim or Star CCM Plus, to what extent do you guys rely on team build tutorial versus the provided tutorial? Are these software in any way easier to learn versus other product?
So we kind of rely on both. It's nice to have, one of the things that we mentioned during the webinar was a lot of our tutorials use internal parts. So parts that we've had on older cars or parts that we're using currently, and using those as case studies really helps students to understand how they'll actually be using those tools within the team. But we do suggest that students get started using, some of the stuff provided by Siemens just to get up to speed and learn how the interface works and learn the high level kind of tool itself. So it's a combination of both, but it depends on the person, I would say.
Yeah, getting familiar with the tool overall, and then pretty much diving into specifically how we use it, and then making sure they clearly kind of understand that and can improve on that process.
Something I would like to add to that, we do have a something I built out called the academic guidance page. I'm going to put that in the chat window just as a link. But if you go to like a Google search and you just type in Siemens academic guidance page, it's a website that pulls all the different resources together, anything from how to get our software to how to learn it, and a lot more, just stuff on like licensing and so on and so forth. But with respect to learning the software, it does outline that there's general resources, like if you go into the support center where you get access to the installation files and stuff. For each product, there's getting started guides, there's a knowledge base, there's tons of content in there. And then on top of that, we do provide access to our e-learning platform, the main one being Accelerator Academy. and that has literally thousands of courses available. And I've taken some of them myself. I can say it's very, very good content. Most of that's kind of focused around just how to use the product, whereas some of the other stuff is more kind of application specific and kind of dives a little bit deeper into kind of specific things that you're looking for. The other element that I'll outline is that we do build content specifically for student competition teams. So over the years, we've built out stuff for FSAE teams, solar car teams, and so on and so forth. For CFD, we just recently published video tutorials that shows you how to build out a chassis in NX and then go in and run FEA on that. A couple years ago, we built out AimSim video tutorial showing you how to use AimSim to run suspension analysis and lap time simulations. So we're constantly building on that and trying to make more competition-specific content, but kind of looping back to that guidance page that I put there in the chat window. If you go in there, we are putting all of that kind of custom content along with any kind of general training content in there. So that's a kind of a good one place to go for everything. To kind of answer the question from Leo, let me actually share my screen real quick and you can kind of see what that page looks like. So that's the guidance page that I was referencing. But under learning, you have general learning resources that I mentioned. I went ahead and opened up the student competition team content section, and you can see there's quite a bit of content in there. I know that the question was kind of focused around Star System Plus, so you can see CFD content for automotive teams. It's right here. So it kind of talks about learning the basics of CFD, and that's just really the fundamental stuff, like what are the turbulence models? When do you use them? What are the different types of meshing? When do you use those? Just some of the fundamental aspects. And then it kind of, I've shown here how to learn the software and then go from there and actually start to apply it to your vehicle. And then that points back to some of these resources about the simulation templates and how to do, wheel and tire modeling, how to set up radiators, some of those kind of resources.